Humankind has always been curious as to what makes up the universe and how it was created. Countless theories have been put up to try to answer questions regarding the nature and mysteries of the cosmos in an attempt to understand how the universe began. Understanding how the Earth began helps in learning Earth, its beginning, and its processes.
In an effort to make sense of the universe, humans used religion, traditions, philosophy, and science to describe its origin and structure. Humankind's most recent understanding of the universe is built upon previous knowledge and enhanced by integrating data acquired from the latest technology. Sir Isaac Newton published his Principia, which described a static, steady-state, infinite universe. A model of the universe assumed by Albert Einstein in his theory of relativity was no different from Newton's. He later abandoned this part of the theory when Edwin Hubble in 1929 showed that the universe was not static. After Hubble's demonstration of the continuously expanding universe, and after the discovery of cosmic microwave background radiation by Arno Penzias and Robert Wilson in 1965. The Big Bang Theory has been the mainstream scientific view. The Big Bang Theory describes the universe as originating from the infinitely tiny, infinitely dense point or singularity between 13 to 14 billion years ago. The essential statement of this theory is usually attributed to the Belgian Roman Catholic priest Georges Lemaitre in 1927. An oscillating universe was Einstein's favored model after he rejected his own original model. The oscillating universe followed the general theory of relativity equations of the universe with positive curvature, proposed by the English astronomer Fred Hoyle and the Austrians Thomas Gold and Hermann Bondi. The steady-state theory predicted a universe that expanded but did not change its density.
There are two popular models about the solar system, namely the geocentric model by Claudius Ptolemy, which states that the Earth is the center of the solar system, and the heliocentric model by Nicholas Copernicus, which states that the Sun is the center of the solar system. During the time of Ptolemy, the geocentric model is the accepted explanation of the different motions of the universe, the Sun, the Moon, and stars, and the 5 planets that moved around the Earth. Their idea of a solar system at that time was the idea of the universe where planets move with respect to fixed stars, with changing brightness, changing speed, and even retrograde motion. However, during the 16th century, Nicholas Copernicus proposed an opposing idea to the geocentric model by developing another model that explained the structure of the solar system. This proposal became the foundation of the Copernican revolution.
Now, let's talk about the theories on the origin of the solar system. First is the nebular hypothesis. Immanuel Kant and Simon Laplace were the first to propose the earliest theory of how the solar system originated. The Kant-Laplace nebular hypothesis presumes that the solar system began as a cloud of dispersed interstellar gas called nebula. The mutual gravitational attraction between particles caused them to start moving and colliding, and they were kept together by electrostatic forces. The resulting nebular aggregates become larger than others, grew more rapidly, and ultimately became the planets. The next theory that we will tackle is all about the planetesimal and tidal theories. Thomas Crowder Chamberlain and Forrest Ray Moulton worked on the Kant-Laplace nebular hypothesis, which became the Chamberlain-Moulton planetesimal hypothesis. They proposed that a star passed close enough to the Sun, creating huge tides and causing materials to be ejected. These smaller masses quickly cooled and become numerous bodies called planetesimals.
How come Earth is the only planet that can sustain life? Well, because there are important requirements that are necessary in order to support life, and that includes the presence of liquid water, the availability of heat source, and the third is the existence of atmosphere. So life would not have begun without water. The presence of water allowed the first photosynthetic organisms to thrive. It is also important to note that the Earth is situated in the habitable zone, or also called the Goldilocks zone. Being in the Goldilocks zone provides just the right amount of heat and provides Earth with the capacity to maintain water in its liquid form. The heat that drives the different systems necessary to support life on Earth comes from two sources: the internal heating of the Earth and the external heating from the Sun. Having an atmosphere greatly influences surface temperature, weather, and climate.
The motions of the Sun and the planets happen simultaneously. The Earth's motion is evidenced by the daily rotation and the yearly revolution. So the Earth's rotation is the amount of time that it takes to turn around once on its axis. So an axis is an imaginary line about which a body rotates. Earth's axis is tilted 23.5 degrees. And there are two different kinds of rotation. First is the amount it takes for Earth to turn on its axis, known as the sidereal day, and the amount of time it takes for the Sun to return to the same spot, called a solar day.
Earth is composed of four basic subsystems: geosphere, hydrosphere, atmosphere, and biosphere. The geosphere refers to the solid Earth. It is composed of naturally occurring solid aggregate of minerals, organic material, or natural gas called rocks. The hydrosphere is the totality of Earth's water, including the permanently frozen parts called cryosphere. The atmosphere is the mixture of gases that surround the planet, such as nitrogen, oxygen, argon, carbon dioxide, and water vapor. The biosphere includes all life forms, even organic matter that has not yet decomposed. It is also in this zone that the interaction between the different subsystems is most dynamic.